Okay, example 2 wants us to use the isosceles triangle theorem. In order to do that, let's talk about the isosceles triangle theorem first. So the isosceles triangle theorem is the first one here. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent as well. So it says AB is 4 and BC is 4. So since AB is the same length as BC, we can say AB is congruent to BC. So AB is congruent to BC. Therefore, the angles that are opposite those congruent sides are going to be congruent. So opposite, if you're sitting opposite of someone, you're sitting across from them. So across from AB here is going to be angle C. And then across from BC is going to be angle A. So angle A is congruent to angle C. And again, they just named them using the 3 points instead. So angle ACB, right, would be the same as angle C. And then angle BAC is the same as angle A. Okay, so that's the isosceles angle theorem. I'm sorry, the isosceles triangle theorem. And then the converse is just the converse of that. So, right, if we did if P then Q, the converse is going to be if Q then P. So if the angles are congruent, so here you have angle A and angle B are congruent. They're both 41 degrees, so they're congruent. Then the sides opposite those angles are going to be congruent. So across from 41 is BC, and across from this, from angle C here, is going to be AB. So AB would be congruent to BC. Okay, so that's the regular, and then this would be the converse to the isosceles triangle theorem. All right, so let's look at our example. Okay, are those not going to go away? Sometimes they disappear and are erased, and sometimes they're not, so I don't know. It frustrates me because I try to make these videos as short as possible. Okay, so an architect is designing a community park between North 1st Street and South 1st Street. The pathways on either side of the pool will be equal in length. So they have DE here and DF are congruent. They're the same length. To protect the landscaping and to minimize erosion, the architect will place a triangular section of triangular cobblestones at the corners of the park plaza. What angle measure should architects specify for the corners in her design? So they tell us angle D here is 50 degrees. Since DE is congruent to DF here, the opposite two angles, it's an isosceles triangle, so the isosceles triangle theorem tells us our opposite angles, the angles opposite those congruent sides are going to be congruent. So angle E here is going to be congruent to angle F. Okay. They give us the measure of angle D, and we know the three angles of a triangle have to add up to 180. So we can do 180 minus 50, right, is going to be 130. So we know that these two angles here have to add up to 130, and they have to be equal because they're congruent. The angles are congruent, so their measures have to be equal, and we know they're going to have to add up to 130 because the three angles have to add up to 180. So we can do 130 divided by 2, and that's going to give us 65. Right? So 65 degrees for both of those angles. So 65 plus 65 plus 50 gives us 180. If that's a little confusing to you, you can put in an X here. Right? And then if that's X, we can also put an X down for F because they're the same measure. So if one of them's X, the other's also going to be X. And then you can do X plus X plus 50 equals 180. Okay. And then you can solve that. That would work as well. You'd get 2x plus 50 equals 180. So you subtract 50 from both sides. And then you would divide by 2 and get x equals 65. Okay, just to look at, well, we can look at their solution too. Yeah, so they kind of formally wrote it out, but we don't need to be that formal. Okay, if we just look at the try it, a little help here for you on the triads. So again, two sides are congruent, so it's an isosceles triangle. And since it's isosceles, the two sides or the two angles opposite the congruent sides are the ones that are going to be congruent. So here's your two congruent sides. So opposite this side would be this angle over here. And then opposite this side is going to be the 28 over here. So since this one's 28, this one's also going to be 28. Okay, and then you can work on finding the value of x, right? The three angles of a triangle add up to 180. So all three of those should add up to 180. Okay, and then if we look at the next one here, okay, again, you have an isosceles triangle, so the two angles opposite those congruent sides are also congruent. So opposite this side would be this blue one over here, this blue angle here, and then opposite the side on the right would be this angle on the left. So then since they're congruent, you know they're equal, you can set them equal to each other and solve for x.